5.5, if h of x is equal to f of minus x, there's some sort of reflection there of where h of x is the reflection of f along the y-axis. All right, so we'll sort that out now. So h of x is therefore equals to 2 to the power minus x. And we need to calculate the value of x for which f of x minus h of x is equals to 15 over 4. So this part here basically meant that wherever we see x, we just replace it with minus x, which is what we've done. So coming back to our actual equation here, f of x minus h of x is equals to 15 over 4 to the power x minus 1 over 2 to the power x is equals to 15 over 4. So just making our exponents positive there. And then thereafter we can sort out our an LCD. So in lowest common denominator of 2 to the power x. So ideally we can multiply this by 2 to the power x and multiply this by 2 to the power x. And once we do that, since it's an equation, we can drop our denominator. So we would then get 2 to the power 2x minus 1 is equals to 15 over 4 times 2 to the power x. Thereafter, we can get rid of our 4, so we can multiply every single other term by 4. Right, so we can multiply this by 4 just to get rid of our 4, and we can multiply this by 4 as well. So in doing so, once we get rid of that LCD, we can have 4 to the power 2x minus 4 is equals to 15 times 2 to the power x. Then after we've gotten rid of all our fractions, we can then get everything on one side and start factorizing. So now we've got a few different terms here. So we would have 4 times 2 to the power 2x minus 15 multiplied by 2 to the power x minus 4 is equal to 0. So what we can do here is to make our life easier, we can introduce a k method here. So firstly, let's modify this expression. So it will be 4 multiplied by 2 to the power x squared. Right, so 2 to the power x or squared is the same thing as, this is our power rule, exponent to an exponent is just multiplied together. So what this does is it allows us to make our bigger power or bigger degree of exponent look like the smaller power to allow us to use the k method. 15 times 2 to the power x minus 4 is equal to 0. And thereafter we can say let k is equal to 2 to the power x, just to allow the factorization process to be a bit smoother. So what we can then say is 4k squared minus 15k minus 4 is equal to 0. And what this allowed us to do is to actually factorize it much easier. So now if we were to factorize this, this would be 4k here, k here, 1 would be positive, 1 would be negative, so 4k plus 1 and k minus 4 is equal to 0. So once we get our two factors, then we can equate it to 0, solve for k. So thereafter 4k plus 1 is equal to 0, k minus 4 is equal to 0, k is equals to minus 1 over 4, and k is equals to 4. But then again, we're not solving for k, so we need to bring back what we said k was. So what was k? We said let k equals to 2 to the power x. So bring that back here. 2 to the power x is equals to minus 1 over 4. And 2 to the power x is equals to 4. So ideally, since it was type of a quadratic equation or applied quadratic within an exponential equation, we should get two answers. But since we have a positive exponent with a negative answer, we can say that this answer is not applicable, and the other answer is, if we solve it for x, we need to get it to the same base. So 2 to the power x is equals to 2 squared And since the bases are the same, thereafter we can equate the exponents. So therefore, x is equals to 2. So this is the, I would say, the easiest way. Alternatively, you could have left out the k method and factorized it immediately if you were able to factorize that. But here you should get a x answer, which is equals to 2.